If you recall, the research agenda for this project called to measure risk in industrial control systems, to take a look at the safety engineering approach within System Stamp or safety engineering, and also to create a simulation. These slides are a high-level review of the content that will accompany this video. The first section takes a look at the research that has been done over the past year. The second section takes a look at a thesis that has been focused on the reliability or the safety engineering approach. And the third is simply research directions that are relevant to the calculation of risk. The first section is covered by a video, a 20-minute video that will accompany the message within which this video will be contained. It takes a look at the domain that we're working on, a field and gas. It does a review of the work that we've done, where we looked at device risk, looking at surface area, patterns, and field intelligence, and then finishes with the techniques that we have converged on, which is attack trees and Bayesian belief networks. The next topic is a thesis that had just been completed that takes a look at cyber physical systems using the safety engineering approach. And as opposed to what we see in the previous section where we're doing a very technical low-level device approach, this is a system-level view. If you recall, the thesis or the central thesis of this approach is that systems don't fail by component failure, but due to the emergent properties of component interactions. And as you can see here, we have a number of those identified. This focuses on failures on industrial control systems, and this will accompany the content that we're going to share. The next two topics that I'm going to talk about are simply new research directions that, although they were not part of the initial agenda, have relevance to risk. The first one is simply applying blockchain properties to that of industrial control systems and taking advantage of the decentralized nature, anonymity, and robustness of these networks. This is simply overviewing here the blockchain protocol in which a new transaction or a new addition to the blockchain gets broadcast to the network. Nodes then compete, and we get this robustness by which any one node cannot cheat, because being able to cheat would imply being able to calculate something faster than the network. And given the complexity of the puzzle that needs to be solved, that would take years. However, the vastness of the network is large enough that it can be solved under 10 minutes. So taking advantage of that robustness, we can imagine a network upon which the control and nodes are put into the blockchain. And we can imagine how this can be further extended to really take this approach on really any type of IT network, OT network that we want to do. There's a number of optimizations and a number of extensions to the blockchain networks that can be used in order to extend to devices that have low memory and are not your typical computer. So this is something that we have been trying out. We have been doing it with Raspberry Pis, and we can take down part of the network without losing the entire network. Likewise, the last topic that I'll mention is simply looking at device risk from a supply chain perspective, leveraging some of the work that has been done in this domain to identify the question of low probability events that have a high impact. Typically, when risk assessment is done, it is focused on previous historical patterns, and without a doubt, addressing the highest concern controls does have an impact. You can manage most of your large risk. You can cover, say, 99% by focusing on the first 20 controls. However, when you look at the case of zero-day attacks, and this by its definition does not have a previous history, these are the potential attacks that can have a very high impact and a low probability of occurring and are not part of your usual risk assessment. So in this case, we're looking at focusing on the impact rather than the cause, and this is something through which we're leveraging supply chain previous work in order to identify this and take it onto a software domain where we focus on microservices and we study the impact of removing any one of those. So this is simply a high-level review of some of the content that we will be sharing. I will send this video as an introduction as well as the rest of the content that I mentioned.